All right, so another round of pictures for us to take a look at the domain and range for. So again, domain, we're looking at what x values are covered. In range, we're essentially looking at what y values are covered by the function. So this first graph, it looks like we're starting, the graph turns on about -3, and we're including it, and then this graph continues to be covered. That arrow indicates that we're going to be covered all the way forever and ever and ever. So what part of the x-axis seems to be covered? Well, we're bounded to the left at -3. We're unbounded to the right, that's infinity. We are including -3 because of the closed circle, and infinity is always open. So there is your collection of inputs, your domain, your set of inputs. All values from -3 to infinity. What about the y? What about my range? Well, looking at what covers the y-axis, the graph starts here, so that looks like it's about -2. And then because of the nice solid line in the arrow, this indicates that we're going to basically shade the y-axis forever all the way to positive infinity. So what bounds me below is 2. What bounds me above is infinity. We're allowed to be equal to 2 because of the closed circle, and then as I mentioned, infinity is always open. So this set, right, has inputs from -3 to infinity, and it's trading outputs from 2 to infinity. Next graph, again we have some arrows. So this indicates that this is going to go on forever and ever. So along the x-axis, we're going to be covered all the time. Eventually, this graph will cover all of the x-axis. So again, a very strong domain, all real numbers, -infinity to positive infinity. The range, however, is not, because the lowest y value starts here at -1, and then we're covered going up and up and up forever. So what bounds me below is -1. What bounds me above is positive infinity. Since I'm allowed to assume that value of -1, we are closed, and infinity is always open. So this function is defined for all value. You can put anything in the function, but you're only going to get something from -1 above as outputs. Alrighty, making things a little more harder. This next function, let me give you a heads up. It's another example of a rational function. Alright, and when you look real closely at it, it looks like right at +2, the graph is essentially ripping itself apart. We call this a vertical asymptote. Okay, and as you guys go through your math careers, vertical asymptotes are classic cases when we have a division by 0. And we already know division by 0 is bad. So when I look at my x-axis, it looks like +2 is not part of the graph because of that asymptotic behavior, but there is graph covering things to its right, and there is a graph shading things to its left, and we go on forever. So when I look at this, the domain, we actually have two sets. So we've got -infinity to -2, right? That would describe this set. And then the other set would be 2 to positive infinity. I'm using parentheses everywhere because we're never allowed to be equal to infinity, and we're not allowed to be equal to 2. Sorry, that should be a +2 right there. Just noted I had a negative. So 2 seems to be kind of an outlier. There doesn't seem to be a graph associated with it, so we're going to throw 2 out. And usually when we connect two sets like this, we use what's called a union. In mathematics, this means or. So my inputs are either to the left of 2 or they're to the right of 2. Parentheses means we do not include 2. The range is also unique. When we take a look at this graph, it seems to be ripping itself apart at 1. So 1 seems to be a value, an output value, that's not included. But there's shading above 1 and there's shading below 1. So the range has two sets. This first set, -infinity up to +1, parentheses around everybody. Second set, we're talking 1 to infinity, and then a union because we're talking about things below 1 or things above 1. So pretty tough situation there. We'll see more of those as we move forward. The other one's kind of unique. It's kind of strange. It's what we call a step function. It looks like we have a series of steps. So when I'm trying to find the domain, again, I'm asking myself what seems to be covered. And By the way, this is still a function because we're open here and closed there, so when x is equal to 1, there's still only one value associated with it. But looking at the domain, it looks like the domain starts at this x value. We're definitely covered, right? There continues to be y values all the way up to that x value there. So we basically have an interval. Despite the steps and despite the jumps, we have an interval of values of x's that continue to create outputs. So looking at my domain, it looks like we start at -4, and 1, 2, 3, 4, 5, 6, go to 6, and this one is closed, and this one is open, so we use parentheses. So that would be the domain for that step function. Now the range, you got to be very careful, because we're asking ourselves what's covered along the y-axis. And what's interesting is between this x value and this x value, the y value is constantly equal to -2. From this x value to that x value, the y value is constantly equal to 1. And from this x value to that x value, we're 3. So despite the fact that the domain is an interval, it looks like my range is discrete. There's only 3 values that are popped out, right? -2 is one of them, 1 is another, and 3 is another. So that is a very unique function, that my domain is actually an interval and my range is actually a discrete set, unique particular values. So that I'd throw that at you guys. So hopefully this is good practice. We're going to take a look at finding domains in some other situations in another video.